welcome to 499C, Introduction to Audio Coding with SuperCollider. If this is your first time using SuperCollider, the page where you can download it is supercollider.github.io. It's free, it's cross-platform, it's open source. And once you download it and install it and open it up, you'll see something that looks roughly like this. As we go through this class, I encourage you to take notes, but I discourage you from typing along with me. In my experience, I feel like the brain only has so many resources, and you can't use it to simultaneously copy down what's happening on the screen and also learn at the same time, right? So, like I said, these are all going to be recorded, so if you need to come back to something, it'll be available. You can skip through the video very easily. So take notes if you wish, but for the most part, just focus on the material. We're going to start with just some core programming concepts that are relevant in SuperCollider, and some which are relevant in general. But first, let's take a quick tour of the SuperCollider environment, which actually contains 3 distinct programs. One of those programs is the Integrated Development Environment, or the IDE, and that's basically what you see here. It's a front-end interface for the programmer to write code, get help, debug, see what error messages are coming up, navigate various documents, change the appearance or behavior of the environment, things like that. So this central area right here is your workspace. This is where you type and evaluate code. It's where you construct your programs. It's where you run your programs. In the bottom right corner, it says post window. This is where SuperCollider will return information to the user. It might be the result of your program. It might be error messages. It's basically one of those 2 things. In the upper right is the help browser. This is where you can access the documentation for SuperCollider, which explains how all the various objects work. There's guide files, reference files, individual help files. There's a browse feature at the top, and there's also a search feature. We'll talk about this a little bit more detail a little bit later. And then the Documents tab, or Documents panel, is on the left here. If you have multiple documents open, they'll all appear, and it's a quick way to switch back and forth between documents. So you can make a new document, and now we have 2, and there's a little tab system which allows you to switch back and forth, and you can see they both appear in the Documents tab as well. You can also go to the Preferences panel, and here in the Editor section you can modify the font, modify the color, and change some fundamental behaviors of SuperCollider. The defaults are probably fine, but as you get more and more comfortable with SuperCollider, you might find you want to customize a few things, and that's where you would do it. So this is the IDE, and the other 2 components are the language and the audio server. So the language contains basically 2 things: the library of all of the classes of objects that make up SuperCollider. So this is, objects are the building blocks of any program. Objects are things that represent data and information and ideas, like numbers, like graphical windows, like oscillators. Objects are huge collection of objects, right, for everything you might ever need. And the language also contains the interpreter, which is a program that interprets, parses, and evaluates your code, and then returns the result to you. And there's a little status bar in the bottom of the IDE, and it says Interpreter Active. So the interpreter is actually running right now. It's alive and well, and it's ready to start dealing with code. When you launch the environment, the interpreter automatically starts. So that's the language, the library of classes and the interpreter. It's the part of SuperCollider that is most recognizable as a programming language. And then the third component is the audio server. This is a fully detached, completely separate program, which we usually just call the server. And it is essentially the audio engine that allows sound to be created, produced, manipulated. It's anything related to sound the audio server is the one handling those tasks. And I cannot overstate that it is fundamentally detached from the language and from the IDE. It's a separate program. It's not running right now. We have the server status window in the bottom right. All the numbers are white and they're all 0. So the server is offline. We can bring it online. We're probably not going to do it anytime too soon. We're going to focus on the fundamentals first. But trust me, we will start making sound in the not too distant future, and it's going to be awesome. So get ready. You could theoretically have one computer running an instance of the SuperCollider server, and you can talk to it over a network by sending the correct messages from an instance of the language on some other computer. You can even use another program like Python or Max MSP or processing or any software which is OSC compliant, which is the language that SuperCollider uses to pass data back and forth between the language and the server. OSC stands for Open Sound Control. It's a topic we'll get to later in the semester. There's an article. This is the sort of seminal article on the development of OSC by Matthew Wright and Adrian Freed. And I think there's also a website open. I think this is just opensoundcontrol.org, which just gives you a little bit about OSC. But it's been adopted as a regular feature of many audio video programs as an excellent way of sending data from one program to another quickly and accurately and with a high level of resolution. Right, so let's move on and talk a little bit about just barely scratch the surface with the concept of object-oriented programming. The SuperCollider language is an object-oriented language, which means its world consists of classes of objects, we do things, manipulate data, invoke actions by communicating with these objects in various ways. So as an analogy, in the real world, we can apply a similar kind of thinking, where the real world consists of objects of different classes, animals, plants, vehicles, buildings, right? The list goes on. And within these classes, you can imagine subclasses, like within the class of animals, we have mammals or something like that, right? Insects. And if we go the other direction, we could say that animals, plants, vehicles, buildings are all part of some larger parent class called things or something like that, right? It's a huge tree of classes in the real world and also in SuperCollider. So there's a sort of hierarchy, and except for the very top, which is the class called object, which is the parent of every class, everything has a parent class, and some classes also have some number of subclasses, right, which are subcategories of that thing. Right? So that's the general idea. And every object has some number of methods that it responds to. I have a colleague, John Thompson, who likes to call methods an object's superpowers. It's like the things it knows how to do, the things it will. For example, you can imagine a method that is the equivalent of asking, are you a mammal, right? This is one of the superpowers of animals. It's a method that makes sense for animals. We can say, here's a member of the animal class, are you a mammal? We're sending this method to the object and we get some result. Now, we can't really do this with vehicles. We can't go to a vehicle and say, are you a mammal? It doesn't make sense, right? So there are some methods that make sense for some classes and don't make sense for other classes, but there are some methods like, are you alive, that make sense for everything, right? You can ask that of anything and it makes sense. So a similar thing goes on in SuperCollider. We have a certain type of object and there's a family of methods that we can apply, which make sense. But other methods don't make sense to it, and some of those methods that don't make sense would make sense if applied to another class. I know I'm being very broad and general here, but we'll get specific shortly. And there's the idea of inheritance as well. So inheritance means if a method is defined for a type of object, it will be defined for all of its subclasses as well. Subclasses inherit those methods. And then there's also one more important distinction to make. We're still being a little abstract here, but it's the distinction between classes and instances of a class. And as an analogy, consider a house, like a real actual house that you can touch and live in, and a blueprint for a house. Right? Now you can live in a house, but you cannot live in a blueprint of a house. But the blueprint provides all of the instructions and information that you would need to construct a house. So in this analogy, a blueprint of a house is like, it represents the house class. It's not a real house, but it's an abstract category of things. Now, the house itself is an instance of that class. You can imagine if you have a class, like a blueprint or something, you could use that one class to make 100 houses, right? They might all be the same. You might be able to tweak the blueprints a little bit each time you use it and make 100 slightly different houses or completely different houses, right? But you wouldn't need 2 blueprints to make one house, right? And so it's the class is kind of this abstract idea whose primary responsibility most of the time is containing the instructions needed to make instances. And then we use the class to make instances, and then the instances are the things we actually work with. That's the usable data that is valuable to us. All right, so with that in mind, let's start writing some code. We're going to put these concepts into practice. And we're going to write a very simple code expression, evaluate it, see the result, and then kind of dissect it. So here we go. 4 period squared semicolon. Right? This is an expression of code in SuperCollider. And to evaluate this expression, we just make sure the mouse cursor is somewhere on this line. And if you've just typed it, it's going to be on that line. So, and then we just hold Shift and press Return. Voila. Right? And we have just run our first program in SuperCollider. It kind of even reads like English here, right? 4 squared, right? 4 squared is 16. And so we see a little flash of color, and we see the result of this code in the post window, and right? So that's that. Now let's unpack what we've just done here. 4 is an instance of a class of objects called integer. Right? It's one of an infinite number of integers. And squared is a method that is defined for instances of the integer class. Right? There are many integers. There are many methods which are defined for integers, but this is just one example. And the period is a syntactical tool, which in this case means apply this method to this, what we call receiver. It's the receiver of the method. Right? 4 receives the method squared, and this is interpreted by the interpreter. It does some work, and it comes back to us and says, here's what you got, right? Here's the result. And the semicolon here is the statement terminator, or the expression terminator. It's the thing which tells SuperCollider, this is the end of my code statement. It's like punctuation in a novel, right? Without periods and exclamation points and question marks, we try to read a novel, and it's very, very hard to parse, sometimes impossible. So when we have multiple lines of code, we need to put a semicolon at the end of each one. This structure here, I like to call it, I think it has a formal name, but I just call it receiver.method. Right? That's what I use to describe this structure. It's not the only syntax option. There's another version where we put the method first, and then in an enclosure of parentheses, the receiver. This is a syntactical variation on the same statement. You'll see a mix of these, both in this class and if you look through the help files. And there are some times when it makes sense to use one and the other. They're equivalent, but for example, 4 squared, it feels correct to do it this way because it reads 4 squared instead of squared 4, which is a little bit unusual. But when we get into things like conditional statements, it says if this, then do that, it makes sense to have the if, which is the method, first. So it's just two variations. It's good to be aware of both. We can chain methods together. Once we apply a method to a receiver, that expression becomes, could possibly be a receiver for more information. Like if we say 4.squared.reciprocal. The reciprocal means take 1 divided by the receiver. Right? So this is going to be 4 squared, and then the reciprocal of 4 squared. So this is 4 squared is 16. 1 divided by 16 is 0.0625. So when we chain methods together in this way, they just happen left to right. And the equivalent down here would look like this. Right, kind of similar, but we start with the innermost set of parentheses and work our way outward. When we run this line of code, it's either one of these. We see a flash, we see a number here, and I want to make a distinction here between posting the result and returning a value. Initially, it might seem like these are kind of the same thing, but they're not quite the same thing. The fact that we see the result in the post window is really a side effect of evaluating code. When we evaluate code in SuperCollider, we always see the result, the result of the last line of whatever we just evaluated. If it was just one line, we just see the result of that line. But also, the interpreter returns a value to us. And this means that the expression we evaluated is essentially equal to some result. And in this case, it's a number. It might not always be a number, but in this case, it is. And so when we get to the idea of variables, which are containers to store data, we can take the result, and because SuperCollider returns a value, we can store it in a variable. Just want to plant this seed in your heads for now, the idea of returning a value versus just posting, which is just kind of a side effect. All right, another method here, pow. Pow, bang, right? Pow, this means power, to the power of. So if we just say for.pow, we get a very intimidating looking error message. And it says error, binary operator pow failed, receiver nil, blah, 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 scary computer code. Now this just means SuperCollider wasn't really able to make sense of what we were trying to do, right? Because for to the power of awkward silence doesn't make any sense. So what we need to do here is actually provide what's called an argument. An argument is an additional piece of information which is required in order for some process, like a method, to work. And we supply the argument by appending a parenthetical enclosure immediately after the argument, and then providing the information it needs. So this means 4 to the power of 3, which is 64. And the equivalent way of doing this is to put the receiver first, a comma, and then the additional arguments. So this means apply the power method to the receiver 4, and 3 is the argument that represents the exponent. So same thing. Here's just one more example. I'm just going to give you a slightly fancier method called lin. So we'll say 0.3 dot lin 0 to 1, 30 to 40. I'll put some spaces in here just to make a little bit extra space here. So lin is a method which maps a receiver, some value, from its position within one range to the equivalent position in another range. So this means 0.3 exists somewhere on the number line, between 0 and 1, and translate that to the range between 30 and 40. So the result here is 33. Right? Because if we count from 0 to 1 and imagine where 0.3 exists on that line, and then we just replace 0 and 1 with 30 and 40, that point is 33. So it's just a range mapping operation. And it's an example of a method which requires more than one argument. So sometimes, we can't just say 0.3 lin some number. We need more information. And just to reinforce this, you can also write this expression like this, and that's the same result. Right? So receiver always goes first when using the method parentheses receiver version. How's everybody doing so far? Okay, excellent. All right, so let's just imagine if we just had this line here, for.squared.reciprocal, and we continued chaining additional methods onto it. Maybe we want to manipulate this number a different way, and then a different way, and eventually it's going to bonk into the right edge here, and it's going to bleed onto the next line. And if we kept doing this, like some kind of maniac, it would just be unreadable, right? It's too many things crammed into one statement. So for this reason, we very frequently will break some multi-step process into individual lines of code. First we square it, new semicolon, new line. And then we reciprocal it, semicolon, new line, more stuff, right? But in order to do this, we need a few more techniques, two in particular. We need to deal with the concept of variables, some way to store a piece of information so that we can refer to it later, right? Because if we just say 4 dot squared, and then we say, okay, something, where's our, we didn't save it, we didn't capture it anywhere, it's lost, right? It printed it, but there's no container capturing that value. So to do that, we're going to declare a local variable, and we do that. Well, we just say var. If you type var, it turns red. Some people are like, ooh, that looks bad. Red means bad, right? But no, it's just a color. You can change the colors. We'll say var num, semicolon, num equals 4, num equals num dot squared, and num equals num dot reciprocal. So just take a look at these lines. This statement says, SuperCollider, I need a container. Give me a container, let's call it num. It says, here you go. And then we say, okay, store this piece of data in this container. This equal sign is not mathematical equality, right? It's not mathematical equality, it's a storage operation. It says store the thing on the right in the thing on the left. And now you can tell, here it's definitely not mathematical equality, right? So what we're saying is perform this operation and store the result in this container. So we're actually overwriting the old value, right? So num is 4, now it's 16, and now it's 0.0625. But we can't do shift enter on this because shift enter just tries to evaluate a single line, unbroken by return characters. So we need to use a different keyboard shortcut here, and we need to enclose this block in a parenthetical enclosure with one part of the enclosure on the top and one on the bottom, each on its own line. This is a structure which lets the interpreter see that this is a modular block that belongs together. And to evaluate this, we place the cursor anywhere inside the block, and instead of shift return, we press, I'm going to say command return, but if you're on Windows or Linux, it's control return. Throughout this class, I'm going to use the word command, because there is no command key on Windows, so it's not going to confuse you. But if I say control, Windows users are going to use control, and Mac users are going to use control, and those are different keys. So when I say command, I mean control if you're on Windows or Linux. So I'm going to hold command, press return, and the whole block flashes, and SuperCollider says, okay, it runs this program, and it returns the result of the last line and also posts it to the post window. Okay. Couple of rules here. One, when you declare a variable in this way, it exists only for that local evaluation. So if we say, oh, I meant to do one more thing with num, and we run it, it says variable num not defined, right? It's gone. It did its job, and then that space is reallocated, right? It's available for whatever else, right? It's gone. So local variables are ephemeral. They're transient, right? They just last for an instant and then they're gone. You can't name a variable anything you want, right? It has to start with a lowercase alphabetic character, A through Z, lowercase. After that lowercase character, you can use lowercase, uppercase letters, numbers, and or underscores. I think that's about it. So no wacky symbols, no hyphens, can't start with a number, can't start with a symbol. So something like my num, this is a perfectly valid, this is what's called camel case, where you avoid underscores. Right? This is also fine. This is the underscore approach. Whatever looks nicer to you, these are all fine. But you can't start something with a capital letter. SuperCollider is gonna think that's a class, and it's gonna get confused. So, and the general rule with variables is short but meaningful. Right? You don't want to have a 20-character variable because it just takes up space and just kind of looks a little bulky. But I also don't necessarily recommend single character variables. Sometimes it makes sense if it's a really short thing you're doing, but most of the time you want to give it some name which at a glance you can tell what it is and what it represents without taking up too much space. Just good practice. Okay. We're not always okay with this transient behavior. There are lots of cases when using SuperCollider when we want to create some container, store some data in it, and then go off and do something else and come back to it later and say, what were you again? Oh, I need you. We can't do that with local variables, but we can do that with one of two approaches. The first is the use of interpreter variables. The 26 lowercase characters, A through Z, are set aside as variable names that you can use, and they will persist. I don't recommend using S. You can use S, but S is actually used for a reference to the audio server. So avoid that one if you can, but if we say A equals 7, right? No complaints. It doesn't say A is not declared or not defined. And then we could even go into another tab and say A plus 3, and look at that. So we can hang on to A. It's not going to lose its value unless the interpreter crashes or something, or if we could quit SuperCollider. The other option is to precede a normal variable name with a tilde, like this. And this is also fine. And tilde num will retain its value. We can use it elsewhere. It'll hang on to that number and won't lose it. These are called environment variables. I'm not going to go into much detail here, but basically in SuperCollider, you're always in an environment. And when you open it up, an environment is created for you. And there's a set of variables that can be named whatever they want. And as long as you don't change environments, you'll retain access to all of these. And this tilde is a little syntax shortcut for creating an environment variable. So that's something to keep in mind. I think I use these constantly, right? And they're a lot better than the interpreters because you have more than 26 of them and you can give them meaningful names. Okay, let's introduce a new method here, and it is going to be post_ln. So post_ln is short for post new line new or whatever. And this is your primary debugging tool. post_ln has the effect of posting its receiver to the post window, but otherwise doesn't manipulate the data in any way. So when we run this code, oh, by the way, I'm using Shift-Command-P to clear the post window. So you can also right-click on the post window and say clear. That's an option as well. So if I run this, take a look at the post window. We see 16, and then we see the posting of the returned value. So 16 is just a consequence of appending post_ln on this line. And so it shows us what num squared is. And we're like, oh, good to know, right? Just in case we're somewhere in the middle of our code and we want to check to make sure something is behaving correctly, that we're getting the right value, post_ln is a great way to do it. Otherwise, you only see the result of the last line and nothing from the middle. Let me also introduce the concept of comments. In programming, a comment is text which the interpreter will ignore. It's invisible to the interpreter. It's just something, it's usually a note for some human reader, maybe somebody else, but it might also be you. Like if you work on a project and you've just solved some complicated problem and you want to remember how you did it, write it down so when you come back to the program a year later, you won't forget. Right? It's just a little note for yourself or somebody else. There's two styles. When it's a single line comment, you can just type a double slash and then just start writing. And we can run this and it's exactly the same. The interpreter sees the double slash and says, oop, that's not for me. And if you want a multi-line comment, like some long paragraph or something, you begin with an enclosure of a /*, and then you can make new lines to your heart's content and finish it off with the opposite order of those two symbols. And that'll work as well. So those are your two comments. And one final note about white space, as it's called. That's the use of space characters, tabs, indentations, new lines. SuperCollider is, for the most part, very indifferent to white space. So, you can do something like this. I think you can even do this. And it's still valid. It looks outrageous. I do not recommend this. But I also don't really recommend cramming everything together. You know, this is okay. This is a lot more acceptable, but you know, it's really an aesthetic thing more than anything else. It's just, I think it's nice to give your code a little bit of breathing room so that it just becomes a little bit more readable, right? But, you know, you can do stuff like this. You'll see some varieties as you go through, but my usual approach is to, you know, these operators, these symbolic operators, just put a space on either side. I think it looks nice. You can do whatever you want, though. All right. Let's turn our attention again to this help browser and cover how we can navigate it and also introduce a few more help resources. So there's the help browser. If you accidentally close it, you can get it back in the View Docklets help browser. You can also pull it out of its little cubby and move it around or dock it back like this. So you can even, you know, move it down here or something. So lots of flexibility. But that's all well and good, but okay, we can go to the browse and we can search by category, or browse by category, I guess, and there's also search. But even faster is the keyboard shortcut Shift-Command-D. Shift-Command-D will bring up a little search bar, and if you type the word, the name of a class or a method, like routine, it will bring up the help file for that class. So, you know, or let's do integer, right? Here's the help file for integer. The usual structure of a help file is a brief description, its lineage, its parent classes, a description, and then various methods that can be applied to the class integer, as well as instances of that class. And then there's often some examples at the bottom, probably not for integer because it's just such a simple class, but probably there's, yeah, throughout the help file, you'll see lots of little code examples that can be evaluated in the help browser or copied and pasted into the workspace. And if you're over here in the workspace and you, let's go back home for a second, you can also click on, you don't have to highlight or anything like that, just make sure the cursor is on the name of a class or a method, and instead of Shift-Command-D, just press Command-D, and that will also bring up the help file. I think I probably use Shift-Command-D most often just because I know there's a class I want to look up and I just type it right in. There's also, this may be a little bit less helpful, but let's just type array, which is the name of another class, .browse. And browse is a method which works on any class and which brings up the class browser, which is a little graphical tool which lets you see methods and the arguments those methods take. You can also access source code files from here. You can also you know, go to the superclass of array, which is arrayed collection, and you can navigate back and forth. It's all pretty self-explanatory. Like I said, this is not the first place to go when you need help, but for maybe more intermediate usage, it can be kind of a useful tool. All right. We've already been introducing types of classes, like integers and certain methods, but let's do a more formal tour of some of the most common classes and methods that you'll encounter. And we're going to start with integers and floats. So integer, we all know what an integer is. It's a whole number. It could be positive or negative or zero. And a float is also a number, but it involves a decimal point. So 1, if we say .class, class is a method which returns the class of an object. So we can see this is an integer. Right? -1 .class, also an integer. But 1.0 .class, despite being quantitatively equal to the integer 1, it's actually a different class. It's a float. 1.0007, that's also a float. So anything with a decimal point is a float. Anything without a decimal, any number, whole number is an integer. Right? And we are going to be dealing with integers quite a lot. And let's get some of the basic numerical operations out of the way. The 4 essential operations, addition, subtraction, multiplication, division. Probably you could even figure these out on your own, but obviously the plus symbol, the hyphen for subtraction, the asterisk for multiplication, and the / for division. There's also, I want to introduce you the, if you've never heard it before, the modulo operator. All right, so this, let's say, let's say 3 mod 12. The modulo symbol is the percent sign. The easiest way to explain modulo is it's division, but instead of the result, you get the remainder after the number of whole numbers, right? So for something like 14 mod 12, it's 14 divided by 12, which is 1 point something. And we get the number of values left over, right? 12 goes into 14 once, but then there's 2 left over. Right? So 15 mod 12 is 3, right? 16, etc. We get up to 24, we go back to 0. Right? So it turns this sort of ascending numerical experience into this thing which repeats, right? Goes up to just below 12 and then repeats and repeats and repeats. This is useful, let's talk about music for a second, for figuring out pitch class, right? MIDI note 61, right? What pitch is that? Is that an F? Is that an A, right? We just do mod 12 and it gives us 1. Right? And if we think of C as 0, C sharp as 1, D as 2, right? All the way up to B being 11, then we can just take any MIDI note number, mod 12, and we can figure out what pitch it is. Right? So just one example of why modulo is useful. And there's also the method mod. This is an alternative to the symbol. Right? 61 mod 12. All right, and this is also very important while we're on the topic of binary operations. These little, these symbols are called binary operators because it's an operation involving 2 values. Right? Now, what about this? What do you suppose this is going to be equal to? 2 plus 3 times 4. In grade school, we are taught that multiplication comes first, and then addition. SuperCollider disagrees. Right? When you have a sequence of binary operations with symbols, they are applied left to right, without any precedence given to any operation. So 2 plus 3 happens first, that's 5, times 4 is 20. Right? If you want to impose precedence, use parentheses, like this. Parentheses happen first. And you can have multiple tiers, multiple layers of parentheses in order to guarantee. And sometimes it's good to use parentheses even when they're not needed because it visually makes it very clear to the reader what is happening. Right? Some people find this very annoying, and I can understand why, but it's a consequence of how SuperCollider is designed. And every programming language involves some sort of trade-off where you have this advantage, but you have this disadvantage. And maybe this is one of those things. And it doesn't matter what the operation is, right? Any sort of symbol binary operator, left to right, unless there's parentheses. What about this, right? How does SuperCollider deal with order of operations here? 2 plus 3 mod 4. Here's the rule. Methods applied with, method receiver or receiver.method happen first, then symbolic binary operators. So 3 mod 4 is going to happen first, then we're going to add 2 to the result. So 3 mod 4 is just 3, right? Because it divides and we get 0 point something and we have 3 left over. So 3 plus 2. But if we did this, then the 2 plus 3 happens first, and then the modulo operation. I know this seems really kind of trivial, but it is quite important because things like this break code when you're not expecting it. So good to know these things up front. All right, so integers and floats. Lots of methods there. Strings and symbols. A string is an ordered collection of text characters, and it's delineated with an enclosure of double quotes. So the string hello, right? Not class. This is a string. It has a size, and the size is the number of characters in the string. And symbols, there's 2 ways to delineate a symbol, with a backslash or single quotes. That's a symbol. That's a symbol. About 90-ish, 95-ish% of the time, you can swap one for the other. In a case where you would use a string for something, you can usually use a symbol. It'll be fine, right? And vice versa. But there are some subtle differences. One of them is that strings have a size, symbols do not. Well, they do, it's just always 0. Right? So a symbol is considered an irreducible unit. It's in the same way that the number 7 doesn't have a size, right? It's just a number, right? And that's maybe a bad example, but you understand what I'm saying, right? A symbol is not composed of individual smaller classes. It's just one thing. But a string can actually be broken down, and we can say, at 1, right? Give me the character at index 1, and that is the letter E, right? Indexing begins at 0. Right? So we say, give me the character at 0, at 1, at 2, at 3, at 4. Right? We can't do this with symbols. Right? Generally, symbols and strings are both useful for naming stuff. Something needs a name, you use a symbol or a string. Booleans, or Boolean is the name of the class. There are 2 Boolean values, true, false. Right? These are essential for dealing with conditional logic to check if some condition is met. Right? Is the amplitude greater than -6 decibels? Right? Or is the frequency of something at least 100 hertz? Right? If so, so Booleans are values that are returned from these types of conditional checks, like 2 greater than 1. That is true. Right? This is 2 less than 1. You could think of this like a question. Right? It's false. 4 dot is float. False. There's a bunch of methods that start with the word is, right? Like asking a question. Is this string empty? Is the size of this string greater than 7? Nope, it's not. It's got 5. Right? So lots of conditional checks that we will run into. There'll be some questions on the homework involving conditional logic. We'll get to it in a little more detail, but right now we're just introducing the idea of Booleans. True and false are special characters, special terms, right? You can see they change color when we type them to indicate that it has a special significance. So this means we can't name a variable true, right? This is actually not allowed, right? That is a reserved keyword. So true and false. There's also nil, another reserved keyword. Nil is the value of something that doesn't have a value. Sounds a little contradictory, right? But if we say, what's the value of x? We haven't dealt with x yet, right? It's just sitting there as an interpreter variable. Oh no, yes, we did. We gave it a value of 7. How about y? That's nil, right? So nil is a sort of special precaution taken so that we don't crash the program when we ask for something that doesn't exist. Right? Everything that doesn't have a value is nil. And you might see an error message that says, message not understood, receiver nil. That's a dead giveaway that you're trying to do something with some object, but you haven't actually initialized it to have some starting value. Right? It's like saying y plus 3. Whoa, right? Can't do that because the operation plus is not understood because we're trying to do it with nil. Doesn't make sense. Okay, and last for today, I'm going to introduce the array class. An array is an ordered collection of things, right? And it's delineated with an enclosure of square brackets. And I'll say 2, true, nil, the array 4, 5, 6, and 8.3. Right? And we'll store this in X. So we have just created an array. Oops. Its size is 5, contains 5 items. We can say, give me the item at index 2, which happens to be nil, because that is in fact the item in the array at index 2. Right? If we ask for the item at index 3, that's the array 4, 5, 6. And so we could even chain these together and say, give me the item at index 3, and then give me the item at that item's index 2. So this shall give us the number 6. Right? You see, because first we index into this array and say, here's the item at index 3, and here's the item at index 2. Right? There's a syntax shortcut for this, which looks like this. We have the array, or the variable containing the array, and then immediately following that, square brackets, and this means this is equivalent to the previous line. Right? You can chain them together. Right, let's oops. Right. So these are equivalent syntactically, and these are equivalent syntactically. Arrays are a must-learn feature of SuperCollider. They are incredibly useful because they allow us to express an arbitrarily large collection of things as a singular unit stored in a singular variable, and we can access individual items with a very simple syntax. Right? So imagine pitches in a scale, rhythmic durations in a set of 4 measures. Right? And all of these things can be modeled with arrays, and it's very, very handy to deal with that sort of thing. All right. I'm going to stop here because we are out of time. Feel free to get started on the homework assignment, which is on the course website. You'll probably be able to get through some of the first questions, which are pretty short and pretty simple. And feel free to poke ahead a little bit, but we are going to finish up this lecture next week. We'll continue with arrays, a few more classes, and then some other interesting topics. So I'll see you next week.